Dear participants, my name is Bircan ÇALIŞIR from Fırat University, Turkey. Today, I will give you my presentation titled Designing Hardware Application of FBMC Transmitter. The content of my presentation is as follows. First, introduction, then OFDM, FBMC, implementation results, conclusions, at least references. OFDM. OFDM uses information bits to generate complex infants and quadrature two components of CNM as seen in Figure 1. After that, M-length and inverse phase Fourier transform is computed and M-complex sample black is composed in time domain. At the input of RFFT, unused subcarriers are path to 0. We can write the baseband OFDM modulation in discrete time domain like equation 1. In equation 1, M expresses the overall number of subcarriers CNM symbolized complex value data obtained from count constellation at subcarrier index M and block index N. A scale represents the complex output of OFDM modulation. At the beginning of OFDM block, a cyclic prefix is inserted to cancel intersample interference that caused by delay spread or multiple channel with considerable higher cost in spectral efficiency. FBMC. FBMC outcome modulation presents similarity to FDM modulation with two main differences as shown in Figure 2. First, COM mapping is realized and followed by offset of M2 samples in time domain between I and Q components of CNM. The components are multiplied by Jm plus M to provide neighbors of a subcarrier in quadrature. The obtained outcome mapper presents the orthogonality in the real field. Next step of this modulation, a filtering process, known as polyphase network, after IFFT block. Thanks to this, a better time and frequency localization is achieved without cyclic prefix. The discrete time FBMC outcome modulator output is given in equation 2. Considering the length of prototype filter L equals Qm. Q is natural number. In equation 2, M describes overall number of subcarriers, G describes the prototype filter of length L. In equation 3 and 4, the delay of filter causes fast components and symbolized with this equation. Implementation results. Prototype filter of FBMC is simulated first in model sim 10.4 and filter input and output are given with Figure 3. Filter in, filter output with clock cycle. After model sim simulation, the prototype filter is realized with Vivado 2017.4 with HDR programming. The obtained display of prototype filter schematic is illustrated with Figure 4 that has a complex structure with 45 cells, 25 input-output ports, and 75 nets. At the end of hardware implementation with XC6Z 020 CLC 400841 FPGA kit. Obtained resource utilization is shown in Table 1. FFT-IFFT structure uses radix 2 algorithm that works for high throughput applications. Used IFFT length is 256 and real and imaginary data are loaded into an internal 256 16 register file. Table 1 presents resource utilization of FBMC transmitter for power, load, flip-flop, input-output, and DSP. Maximum power consumption is obtained in IFFT application because of its complex structure. Also, utilization of load, flip-flop, input-output port number, and DSP are more used for IFFT application. The number of flip-flop for OCAM processing is little higher than prototype filter processing, while load utilization of OCAM is 343 higher than prototype filter. Take into consideration reference 8, Table 2 is formed for comparison with our proposed study. In Table 2, since used IFFT length is 512, processing complexity doesn't show fair comparison. Due to structure of IFFT and prototype filter step doesn't exist in this table. Naturally, and number of input-output is not presented by authors. When total chaos is considered in Table 2, total power, consumption, load, flip-flop, and DSP consuming of IFTM are more higher than FBMC for all these reasons we explained. Conclusions. This paper presents a study investigated on FBMC for next generation communication as 5G mobile candidate. The prototype filter of FBMC is designed and simulated in model sim program. Then, the same prototype filter is realized in vivo with HDL code in FPGA kit. The transmitter of FBMC was realized in MATLAB in previous studies. So, transmitter of FBMC applied on FPGA with HDL code production. This paper concludes with comparison of them application with our proposed study and conclusions are given with tables. This paper exhibits that FBMC is very strong candidate of 5G for next generation communication systems. Our references are here. And thank you for your listening.